So in part C1, we're given this proton moving in a circular path, and we're told that the magnetic flux is directed into the page. We need to draw a direction for the velocity of the proton. So for this, we simply can use the right-hand rule, and we will see that if the proton is traveling down, then if we point our thumb in the direction of the velocity or the rest of our four fingers into the page, then our palm will be facing towards the center of the circle, as we need a centripetal force pointing towards the center of the circle. So this will have to be the velocity vector. And then in part C2, we need to show this relationship. So what we need to do here is to use the fact that the centripetal force is equal to the magnetic force. So mv squared over r is equal to qvb. We can rearrange this for the velocity. We will get this as E or Q. And since we have proton or electron, it doesn't really matter. We can just say E, B, R over the mass of the proton. And well, what we know is that velocity is simply distance over time. So what we can say is that velocity is distance over time. So time is distance over velocity. And we know that the time period is going to be distance is the circumference of a circle, so 2 pi r over v. So what we can do now is also see that the frequency is 1 over the period. So frequency will be equal to v over 2 pi times r. And so what we simply need to do here is, well, plug this into here. So we remove the velocity term. So we plug that there. So we will find that the frequency is simply EBR over the mass of the proton divided by 2 pi r. If we cancel out the r's, then we will simply find that this is EB over 2 pi MP. And in part C2, we're given the magnetic field strength, and we need to calculate the frequency. So all we need to do is plug in here. So we know the charge is 1.6 times 10 to the minus 19. From the question we're given this B is 2.5, 2 pi, and then from the data booklet we know the mass of proton is 1.673 times 10 to the minus 27. So that would be 3.8 times 10 to the 7 hertz.